Hi, my name is Daniel Buddin, and my STEM capstone project is measuring the impact of wildfire burn severity on soil nitrogen and phosphorus levels. Here in Colorado, wildfires are an unavoidable topic for anyone who values our outdoor spaces. In the last 5 years, 4 of the 5 largest wildfires in the state's history have occurred, devastating millions of acres of forest. In order for these burned forests to rebound, it's highly important that their soils contain all of the nutrients necessary for plant growth and recovery. But when the soils are also dramatically affected by the wildfire and vital components of nutrient cycles like enzymes, microbes, and the plants themselves can't survive, it isn't easy to determine how difficult it will be for these nutrients to regenerate after a fire. My project examines the effects of the East Troublesome Creek fire on the soil nitrogen and phosphorus concentrations in areas that were severely burned. With the help of my mentor at the Colorado School of Mines, Jacob Peterson, I analyzed soil samples taken from 2 areas of the East Troublesome burn. These areas are very close to each other, but under the U.S. National Forest monitoring trends in burn severity metrics, they are classified as one as unburned and one as high burn severity. It's important to note that these metrics use pre and post fire images and compare the amounts of vegetation in each one. So just because one area was marked as unburned severity doesn't mean it wasn't affected by the fire at all. It just means that it didn't lose as much vegetation as other areas. 16 soil samples were taken from each of these regions, and we processed these in the lab, involving shaking them up in ultra-pure water, separating them in a centrifuge, and extracting their nutrients in solution. The samples were tested for orthophosphate and total inorganic nitrogen, and these compounds were chosen because they are most bioavailable, meaning that essentially these compounds are in the soil and plants and organisms can easily use them. On average, there was a significantly higher orthophosphate concentration in the unburned soils than the high burn severity soils. This difference could be explained by the unburned soil generally containing more organic matter. The presence of plant matter and visible root systems in the soil points to effective nutrient cycling. The soils from the high burn severity region generally contain much less organic matter, potentially meaning that the soils there contained insufficient phosphorus to support a living plant and organic matter ecosystem. The total inorganic nitrogen test did not show a significant difference, and statistical tests show that this was likely due to random variance in my samples. The higher orthophosphate concentration in unburned soil suggests that the presence of plant matter needed to cycle these nutrients is really important in maintaining healthy soil phosphorus. That when a wildfire removes organic matter from the soil, it is difficult for the environment to regenerate healthy soil phosphorus. By analyzing the presence of other nitrogen and phosphorus compounds in soils with similar levels of burn severity, I could do some future research that would provide a much more representative image of the soil's overall nutrient health. Thank you for listening.